Victor, can you hear me? Hello? Can you hear me?
Hello, can you hear me? Yeah,
Yes,
I can
yes.
hear
All right. Okay, great, Victor. So good to see you. Good morning.
you.
How
Yeah,
are you?
I'm good. How are you?
Great, great, great. So have been more and more adaptive at the hospital environment now.
Oh, jeez. Interesting.
People get used to things. Yeah. So I think it's important to make sure you are in good health, good environments. Yeah.
Yeah.
Okay. All right. So you like to update? Maybe start.
Yeah.
Okay. All right. Yeah. Go ahead. Please share about your gains and what you've done.
Okay. Um, so a lot of what I have written is on paper, but I'm just gonna try to describe them here.
Okay. Sure.
Trying to draw some of these things this morning. Um,
Mm-hmm.
so I tried to put can you see my screen? Yeah.
Yes.
Um,
Yes. I can see it. Yep.
I tried to
Mm-hmm.
put some stuff on paper
Mm-hmm.
in
Right.
terms of just drawing out the process or like a practical scenario.
Mm-hmm. Right.
Again, the fun diagram is not so great, but
Mm-hmm.
it gives a basic overview of
Mm-hmm. Right.
what I was thinking. So, in this simulation uh, series or process, I have a source and I have a destination.
Mm-hmm.
And I'm basically saying, okay, I want to make a request to that destin. Well, not saying that it doesn't know about the destination,
Mm-hmm.
but I want to make a request that we know or it's in that destination. So the question becomes what's the best way
Mm-hmm.
to forward there. Now, when I look at
Right.
this, this is connected to this
Mm-hmm.
from the
Right.
Verona layer. This
Right.
is and connected to M2. So those are the two
Mm-hmm.
enclosing neighbors of the source.
Right. Right.
This is also connected to M3 and D, and M1 is connected to just M3.
Right. Right.
So there's a bit of a potential redundancy clash here.
Uh-huh. Right.
And the idea was, okay, how do I, find a way to sort of find the shortest path
Mm-hmm.
without M2 knowing about M1 and or should I say yeah, find the
What?
shortest route. Yeah.
Right.
Well, from our perspective, the shortest route is M2. Well, I
Okay.
think
Okay. And
I
to
could be
D.
wrong. I'm not sure honestly, because it
Mm-hmm.
could be M2 to M3 to D.
Okay. Okay.
But I'm trying to look at it, and from what I see, especially from the Vorocast paper,
Mm-hmm.
I noticed that there was a bit of I sort of understood the math. Well, I had the picture of the mathematics sort of equation there, where it was basically talking about the parent and the child,
Mm-hmm. Right.
and the idea is M1 becomes a parent of M2 and M3,
Mm-hmm. Okay.
right? And once you are, oh sorry, what am I saying? M2 becomes a parent of M3 and D.
Right.
But once M2 becomes that parent of M3 and D, then M1 cannot or should not be allowed to
Okay.
become a parent of the same.
Okay.
Um, I have a question for why that is, but that's not
Okay.
that's for
It's to
later. But
avoid redundancy, essentially.
oh, okay,
You see, because if there are two, then like what you're drawing now, you have two, I think two lines point to destination D,
yeah,
right? So that means
yep.
the same packet.
Mm,
It could be just forwarded to the same destination.
okay,
But essentially, the idea is to have a packet or a request to send and receive only once by
okay,
the relevant nodes. Yeah. Okay.
um,
Does that make sense?
okay, yeah, it does, it
Okay.
does.
Yeah.
But I'm thinking of like, what if the information is stored
Uh huh.
already? For example, that okay, like a main parent,
Right.
or the same way you have like a your biological parents and your foster parents,
Mm-hmm.
where the
Right.
main parent can be the one that's shortest,
Mm-hmm. Right.
and the foster parents, which can be multiple, are just like the parents that um,
Okay.
they come in when necessary. So
Right.
the idea is by having that list stored somewhere,
Mm-hmm.
which I know we're trying to save space and everything, but
Mm-hmm.
by having that list somewhere, there's a
Mm-hmm.
sense of competitions can happen on
Right.
the M1
Right.
by comparing, okay, I have all these parents, but which one is the fastest? Because
Right.
um, so I sort of saw a clash. I don't know where this,
Okay.
for example,
Yes.
is a parent
Okay.
of those two, but then if I made this a parent, what if this was the shortest route to
Mm-hmm.
take?
Okay.
But
Okay.
then I don't have the information about that because
Mm-hmm.
in theory M1 does not know about M2,
Mm-hmm.
and I don't
Okay.
know. Anyways, it's just a picture I have in my head. It's still not hundred
Okay.
percent clear yet. But the idea now is okay. Instead of parents, I was trying to avoid plagiarism a bit, so I
Okay.
just
All
called
right.
it this.
This is a good point, and like to feedback quickly.
Okay.
Um, at any given time. Okay, let's
Yeah.
say you're taking a snapshot or a freeze of the global view.
Mm,
There is only one optimal configuration or
okay.
one optimal spanning tree.
Yeah.
Does that make sense? It
Yeah.
means that at the given configuration, it's either through M1 or through M2 is the best shortest path.
Yeah.
There's a definite answer to that.
Mm,
Okay, at any given time.
yes.
Okay,
Yeah.
however, it can change if the nodes are moving. That's one thing.
Mm,
Okay, and
yeah.
also it can change if, let's say, you actually have a packet loss or a failed node. If a node
Uh,
fails, you see, then you actually some nodes may not receive as a result of that. Do you see that?
yeah.
Okay. So what you say, I think, is also important when you talk about parent and foster parent.
Mm,
And I see that as some kind of redundancy mechanism that
yeah.
provides better safety and guarantee.
Mm,
Okay.
precisely.
So I think that is also an important consideration. But then there's the problem of how much redundancy do you want, you see, and whether it can be tunable. Tunable meaning that maybe it's a trade-off between safety, redundancy. I mean, basically safe and redundant on one hand, and efficient, right?
Okay.
Efficiency on the other hand.
Yeah.
Okay.
Yeah.
So, did you see what I'm saying?
Uh.
I, I'm
Yeah.
so
Yeah. Okay. Okay.
if
Okay.
you
Yeah. Yeah.
if you have more redundancy, it's safer, right? Because you actually are more fault tolerant in a sense
Mm,
that even if let's say your parent fell, your foster parent can still send and relay, right?
yes.
But on the other
Yes.
hand, under normal circumstance, if nobody fails, then you will end up with redundant packets,
Mm,
right? Then obviously redundant packet is fine as long as it's not to overwhelm,
okay.
okay, and it doesn't cost like too much extra bandwidth. Like for example, like maybe a 30%, 20 to 30% increase in bandwidth is okay, right? To provide
Yeah.
safety. But if the redundancy is like 100% or like 200%, do you
That's too
see?
much. Okay. Okay.
Okay, especially if you are there's more space, because you can think of an extreme case where there's no discernment about the forwarding. Like every node, if it receives, you just forward to the outbound direction.
Mm,
Okay,
mm,
and just imagine if you are forwarding over like 10 hubs. Let's say maybe it's a 1 kilometer forwarding radius. Okay, those at the edge, you can imagine what happens, right? It's
yeah.
going to receive like a ton of redundant messages.
Mm,
Can you picture that?
yeah.
And
Yeah.
obviously, that's the safest, right? You definitely want to miss any packets. But on the other hand, it's also very inefficient.
Yeah. Sort of stuff to
So,
send.
can you,
Okay.
yeah, can you see what I'm describing?
Yeah. Basically, there's a pros and cons for
There's
every
a
approach.
trade-off. It's a trade-off. Okay. So there's obviously and obviously on the other hand of the extreme is there's no redundancy. Okay,
Okay.
like every node only receive the relevant packet just once.
Okay.
Okay. So between the
That's-
two, you know, no discernment, always forward, and the most efficient forwarding, no redundancy. Right?
Sorry, Shinyan.
I mean,
Uh,
yeah,
you
hello,
broke up
hello,
for
can
a
you hear me?
second there.
Yeah, all right, can you hear me?
Yeah, I can hear you now. Can you just repeat
Yes,
that? Sorry.
yes. Okay, yeah, no, I'm saying between the two extreme, okay, you can probably
Mm.
find that, there's, I think the ideal is if we have something that's tunable,
Okay.
okay, tunable.
Mhm.
So
Mm.
would that be all right? I mean, as an explanation?
Yes, yes.
Okay,
I'm still gonna come back to the recording again, but I get the picture. I
okay,
get.
okay. All right, all right. Okay.
Yeah.
So
Um,
I guess
but
any other updates on your part?
yeah. So, but then the idea was there will still sort of be a need to store the information. Well, not all the information, but some sort of reference. For example, now when source sends to M1, there has to be a sense of um okay, because M1 is still connected to S. You don't it has to know that okay, I'm the parent and this is the child. And if I'm the parent of this child, I should store that like okay, uh it's a bit tricky, but it would have to be done like a how do I put it now? It's like a temporary storage that deletes after the process is complete, or after the sequence is for example, like only store that information when there's a request that's received.
Right, that's true. It's called transient data.
Okay.
So it's not
Okay.
persistent. It's
It's not.
transient.
Yeah. No,
Yeah.
yeah. Okay. Okay. But it's still a bit of a fuzzy approach, and I'm still trying to design it again on paper. I'm thinking I've been trying to read up more again on potential forwarding mechanisms, but in terms of just for example, when when these two become parents
Mm-hmm.
or source
Right.
batches, how do they? How does this know that I have taken ownership of being a parent, for example?
Oh,
You know,
okay. You okay. So there is a basic rule that each node can determine by itself, and it doesn't need to rely on anybody else.
okay,
Okay. And in fact, even coordination is not necessary. Okay.
mm,
There,
okay,
and the way it basically is to determine if I should forward, let's say from M1 to M3, if I need to forward to M3, it's
yeah,
basically the question of let's draw a line between S and M3,
okay,
okay, and see if I'm the closest node on that line than any of my other neighbors.
okay.
So M1
Um,
can ask that question by itself, okay? Same as M2. M2 can also ask that question on its own by itself. For
so
example, if M2 is trying to decide if it needs to forward to M3, you can draw a line between the source matcher, between S and M3, and ask the question, am I the closest one? You
like
see?
that.
Yes, and from the line you draw, you can clearly see the closer one is M1 and not M2.
Okay,
You see that? So
okay.
in that case, M1 will forward to M3, but M2 should not forward to M3.
Um,
That
so
that
the
is that clear?
so we're saying that the layer is already doing that.
Yes, yes.
Oh,
When
okay. Oh,
yes, and
I'm
there's no coordination that's needed actually.
Okay.
You do need to have one thing though, which is the accurate position
Yeah.
knowledge of all the
Yes.
neighbors,
Yes.
or
And the layer already
the,
has that.
right, the up-to-date positions of the neighbors. But that is the only assumption you have to make.
Okay. So I'm just trying to write it down. Okay.
Okay.
So the unwritten rule, if I just get it correctly, is the layer already knows which one should be the parent. It already has the shortest path information, and it already knows, it doesn't need to ask M1 or M. It doesn't need to go. M2 doesn't need to know if M1 is the parent, because S already
Exactly.
knows what the shortest path is, and it
Well,
has decided.
the key is both M1 and M2 can determine on their own, simply based
Okay.
on neighbor position knowledge,
Okay.
that who is the closest.
Okay.
See?
So if I'm not the closest, in this case, yeah. So wait, sorry, I'm just trying to see what's the shortest path here. So in this case, this is the shortest. To
Exactly.
this is the shortest, yes.
Right.
So by default, we can query the layer to just say okay M3. So once this this forwarding request has been made to M1 and M2, already M1 automatically becomes the parent.
Exactly. That's right.
And
Yeah.
because I'm the parent, then this is basically useless. Well, I don't want to use the word useless, and
It just does
then I
not forward. It doesn't keep
doesn't
forwarding.
forward.
That's
Yeah.
all. Yeah.
So it's a yes no if I'm not the parent. Okay, then it makes
Right.
not
And then you can keep asking the same question towards D.
don't
Okay.
forward.
Between D and S, which is the closest?
Okay.
Okay. You can draw a line between D and S, right?
Yeah.
If you draw another line between D and S, okay, and again, you ask the question, who is the closest node to that line? And what is your answer?
Okay. I'm trying to say it's in M3.
Exactly.
M3 is
So then the question, so this answers the question between M2 and M3, this answers the question whether M3 should forward it to D, and also whether M2 should forward it to D.
yeah. Okay.
Okay, so you know the answer, right?
Mm. Okay. So it
So
should be
M3
M3.
needs to forward, but M2 does not.
Mm. Precisely.
Okay,
Okay. So it's okay if yes, no, I'm like a boolean basically, and we already have that.
exactly. So the line between M2 and D, that should not happen. That that forwarding should not happen.
Okay. 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 No, that's fine.
So after you draw this, can you see that there's a spanning tree that
I see that.
basically forwards from S to M2? That's one. Okay, that is still a valid forward. But then it's from S to M1 to M3 to D.
Mm.
Okay,
Okay.
and this can be determined very clearly visually, on the geometry, simply based on positions.
Yeah. Okay. Oh, nice. All right. I think that makes sense. All right. So I guess the forwarding model is sort of simple.
It is simple. It is. It's not difficult. I mean, it's not too many steps. Not, no.
Okay.
It's very simple conditions.
Okay. Just like 2 or 3 yes or no questions to be answered to reach the destination.
Exactly. All you have to ask is the question of whether I should forward to that neighbor is a matter function of, am I the closest node between that neighbor and the source?
Mm.
That's the only one question I have to ask.
Okay.
Okay.
Oh yeah. Uh, um, because the request already contains the spatial data,
Exactly.
so you can compare.
It's an intrinsic property, if you really
Slip.
think about that.
Yeah.
It means that if you have a bunch of dots and you're trying to draw a spanning tree connecting all the dots, right? That originates from a center point to, let's say, a circular area. There's actually just one spanning tree that can be drawn.
Mm,
You, can you see the validity of that statement?
yeah.
Meaning that the shortest path graph, the shortest path spanning tree is unique. There's only one. And that makes
Yeah.
sense, right? That
Yeah.
makes sense,
Yeah.
right?
Yeah.
I mean, because
Only one.
shortest by definition is that if you add the length of all the edges, right, that connects all the dots, all the nodes.
Mm,
It should be of minimum length or minimum distance,
true.
right? I mean,
True.
there's probably only one solution to that, right?
Yeah.
Right? So that's what we're
Yeah.
determining here. Yeah.
Makes a lot of sense. Yeah. So on every request, we basically there's like a spinning tree for every request. And in a real time perspective, it's almost like for every move or leave or uh join functionality, there's a sense of update the system and develop a new spinning tree.
Mm-hmm. Right, right. I mean, you have to sort of see it this way, that spanning tree is an intrinsic property of the node positions.
Yes.
Okay, it's intrinsic. Whenever you have a bunch of dots, nodes, you can have a spanning tree. And the even more interesting thing is, this is regardless of Voronoi. This has nothing to do with Voronoi diagram. You
It's
see that?
XY positioning.
Right, it's simply positions. And what Voronoi can help is to determine the neighbors, right?
Neighbors.
Because it can, well, in a sense, it still is relevant because Voronoi determines what are the nearest neighbor. Okay, who are the
Yeah.
closest neighbor you should consider forwarding to? That
Mm,
is something the Voronoi diagram can help.
okay.
Okay,
Okay. Oh,
but this is
nice.
equally valid. This is note. This is equally valid, even if you switch it to a rectangular, square base, hexagonal, triangular partitioning.
Any type of partition, as long as there's
Yes,
the
and
positioning.
yes, any kind of partitioning, you can apply the same rules.
So the partitioning is just optimizing. It's not necessarily I mean, when I say optimizing, it's just making sure it's the nearest. I mean, it's giving
Right,
you
right, right. Exactly, exactly.
better
Right,
options to choose
exactly.
from.
And in some way, Voronoi is the optimal partitioning.
Partition.
Can you see
Yeah,
that?
yeah.
In some sense, yeah. So I think these are aspects you can definitely discuss, and in the paper or to describe. Okay.
Mm.
All right.
So quite,
So,
it's quite
okay.
interesting.
Yes,
It's
yes, it
quite
is. It
interesting.
is. That's the beauty of math. Although I wouldn't say I'm good at math, but I do admire, the mathematical properties that exist.
Okay.
It is elegant and beautiful in a way,
Mm.
once you can see it.
Yes, what you can see. Exactly.
It's very elegant, right? Once
Yes.
you can understand.
Okay. It's not magic or
Yes.
something you pull out of a hat.
Yeah, and part of the elegance is that simplicity, when you get to the best solution, you usually find that it's actually quite simple. It's not very complicated.
Just took a bit of time. All right. All right.
Yeah,
Uh,
but maybe it's worth it, right? Once
yeah,
you
yeah,
can
definitely.
understand. Yeah,
Once you get it, you get it. It's you
right.
can't unlearn what you've learned.
Right, right, exactly, exactly.
All right.
All right.
All right.
So, Victor, tell me what you're going to do next. All right.
So what I'm going to do next, I'm going to clean up the paper
Okay.
At least, especially the introductory. I have started. I don't know. I didn't open it in time. Flip. Okay. I have started it. But I want to send at least the first into the key part, which is the abstract, the introduction,
Mm-hmm.
and the research problem and what we are proposing.
Right.
That's the first important.
Okay.
So I want to clean that up to make it as perfect as possible because I think
Uh-huh.
we've already done that. But
Okay.
there's like little things here and there. So I'm just gonna send that as well on the group.
Uh-huh.
After sending that, I'm gonna clean up the what do you call it, the our approach section,
Uh-huh.
uh,
Okay.
in,
Right.
in terms of what we are proposing, and our design, basically like the flow charts, and I think I'm gonna include this forwarding part as well
Uh-huh.
as to what
Okay.
the forwarding model is.
Right.
uh, Also, I'm hoping to do that. I'm trying to pull an all-nighter today,
Uh-huh.
and the idea is by the end of Friday. And I don't know
Uh-huh.
if you're available tomorrow, but
Okay.
by
We
the end of
can we can
Friday,
have another thing tomorrow.
another
Actually,
sync
I
for
like
the
to have another
documentation.
thing tomorrow as well.
All right, thanks.
Yeah, at the
And
same
then,
time.
yeah, yeah, thank you, Shanyan.
Mm-hmm.
So,
No worry.
but end of Friday, like the documentation in terms of the structure is perfect,
Mm-hmm.
and then the weekend is just for experimenting, like all
Mm-hmm.
kinds of data. Or sorry,
Okay.
all kinds of um, reports or generated
Mm-hmm.
reports in terms of, for example, bandwidth and just simple stuff. It doesn't
Mm-hmm.
have to be
Okay.
so
Okay. Sure.
complicated.
Sure.
Like basically preliminary results.
All right.
Um,
Okay.
maybe get some feedback on Monday morning.
Okay. Sure.
From what I gather, I think deadline. My time is a bit different
Mm-hmm.
in terms of the deadline. So on Monday, it's due at midnight, or
Okay. I see.
basically
Okay.
on Tuesday.
Right.
Actually,
Right.
it's Tuesday at 2 p.m.
Okay.
So
Okay. Sure.
technically, we still have a bit of, but I don't want to risk it. The
Right.
idea
Right.
is on Monday, I'm showing you guys results,
Right. Okay.
then you're making one or two changes or
Okay. All
rerunning the
right.
code, run the experiment for
Right.
different parameters, and then
So one thing to remind is you can send in multiple versions of the same draft or same submission. So make sure you send in one draft, one
okay,
ready.
okay.
Okay. And then you can keep updating the PDF.
Oh, nice,
Okay.
yeah.
As you
Oh,
have
yeah.
more versions. That's just a small tip. Okay.
Okay,
Yeah.
okay. Oh, the same draft.
All right.
Okay.
Okay. All right. So I guess any other questions?
For now, I think I sort of already have
Okay.
the
All
direction
right.
to follow.
Okay. Okay. All right.
Thanks so much.
So how do you feel about this?
I feel good. I like that it's coming together real good.
Mm-hmm.
It sort of paves the way as well for the proposal,
Mm-hmm. Right.
because
Right.
in terms of the problem statement and what we're trying to accomplish,
Right.
it's quite. I'm even thinking now maybe I should start making the idea a bit more public
Mm-hmm.
in
Right.
terms of
Right.
like submitting it for competitions or something,
Right. Right. Nice. Nice. Good.
just for like feedback mostly, not
Okay.
necessarily to make profit, but like
Okay. Right.
start
That's nice.
basically getting the topic out from decentralized, distributed,
Mm-hmm.
spatial, publish subscribe
Right.
systems as a
Uh-huh.
potential solution for scalability problems or
Mm-hmm.
issues.
The scalable
Uh,
delivery platform. Right.
exactly,
Remember that. Okay.
exactly. But it's coming together nicely, and I'm thank you for that as well. I think you've been very,
Okay.
very, very helpful.
Okay. No worries. If I can help. So
It's been
I like to basically remind that, remember that it's always a gaining and a learning process. Okay.
yeah,
You're always gaining and learning. Okay.
okay,
If you are, having, I guess, the right attitude and mindset, you are always learning and gaining. And that is what's more important. Okay.
okay,
Than any
yeah,
results, in the process.
okay,
And the point this time is still, to make the shot.
Mm.
Okay, you miss 100% of the shots you don't take.
Yeah.
Okay,
That's a
just
really
remember,
powerful one. That's a
yeah,
very powerful.
just remember that. And I would also, I guess, as a last remark, don't worry too much about the simulation. I think for this paper, if you can describe the problem well, show the importance, and then clearly articulate your proposal, okay, and explain the design, I think that would still make a good submission.
Okay.
If you have time, though, obviously you can add the simulation part. But even
Alright.
just describing what you plan to do for verifying, validating, I think that would be enough.
All right.
Okay.
Makes sense. All right.
So focus on one thing. I guess that's, make sure that the problem description and the proposal, okay, the solution part are clearly explained. Okay, I mean, I guess that is where make sure those parts are done first before getting more polishing with the simulation results.
All
Okay,
right. I'll do that.
all right, okay. So that's the priority. Okay.
Yeah.
All right,
Thanks so much.
so I guess good luck. Take care,
Yeah.
and we'll talk tomorrow then. All right?
Yes.
Okay, all right.
Definitely.
Take care.
Thanks so
Yeah,
much.
bye-bye. Yeah, bye.
Bye.